GMAT all day.
In the previous video, we talked about how sometimes you can get away with not actually having to solve for your absolute value equations or inequalities, depending on the question, as long as you just know your basic properties of absolute value. So now let's start talking about when you do actually start having to solve for or break down your absolute value expressions. And so there's really only two ways to solve for an absolute value equation or inequality. You can either try to do it algebraically, and in that case, you are sort of proving the answer to yourself, or you can test numbers. And algebra, as I've said many times before, is usually my preference. This brings up the question, though. So when can I do algebra on my absolute value expressions? Well, I can do algebra when I can get rid of the absolute value sign, those two vertical bars that make up the absolute value symbol. And so let's start talking about what I mean by that by taking a bit of a detour. It is not a big stretch to say that on the GMAT, there are only four mathematical symbols I care about that I want to see on the page. And those are the plus sign, the minus sign, the multiplication sign, and the division sign, whatever you call this thing. Almost any other symbol that I see, I think of as meaningless, and I want to get rid of it. I want to put it in terms of one of these signs. And so even something as simple as the percent sign, if I were to ask you, what is 50% of 60? You might just reflexively say, oh, that is equal to 30. But really, what you did in your head, perhaps subconsciously, is you said this percent sign is meaningless. And percent, what it really means is divide by 100. So 50% really means 50 divided by 100. Of means multiply in this context. And so 50% of 60 really means 50 over 100 times 60. And that is what is equal to 30. Now, bringing this back to absolute value, how does this relate to absolute value? Well, with absolute value problems, I'm trying to do something similar. My goal is to get rid of the absolute value symbol so that then I can solve absolute value problems just using simple algebraic operations like I have here. This brings up our next question is, when can I get rid of my absolute value sign? So to start seeing when I can get rid of my absolute value sign, we will look at the simplest type of absolute value expression. And those are equations or inequalities where you only have a single variable that is under a single absolute value expression on one side, and you are comparing that to a single number on the other side. And for these, I'm not really even doing algebra. I have these basically memorized. I can translate them in my head without having to think about it. And you want to be able to do the same so that you only have to spend time setting up complicated absolute value problems. So we'll start by looking at these two simple absolute value equations, and then for simple absolute value inequalities, I will illustrate those with a GMAT data sufficiency problem. Note here, both of these examples follow the pattern I mentioned before of just having a single variable on one side, and we are comparing it to a given number on the other side. That's what makes these in the category of simple absolute value problems. And this first example is about as simple as you're going to get with absolute value expressions. Absolute value of x is equal to 12. And so recall, absolute value means a distance from a 0, which means this is saying x is 12 away from 0, which means if I want to get rid of my absolute value sign, this just means x is either equal to 12 or x is equal to negative 12, because both of these two values for x are 12 away from 0. And here I have solved this equation for x by getting rid of my absolute value sign. In our second example, this is not that much more complicated. We still have just a single variable under a single absolute value sign, and that is equal to a number. So if absolute value of x plus 2 is equal to 5, that just means x plus 2 is 5 away from 0. And if I want to get rid of my absolute value signs, I can just say, now it is x plus 2 that is equal to either 5 or -5. Then I can just solve each of these equations to get x, and so this means x is either equal to 3 or x is equal to -7. And so these are probably the simplest type of absolute value problems, equations where you just have a single variable that you are setting equal to some number. So now let's take a look at a GMAT problem to learn about simple inequality absolute value statements. This problem says, if x is an integer, what is x? So there is not a lot of info in our prompt other than x is an integer, which is absolutely worth noting. But after that, there's not much we can do. But look at our statements and note, just from glancing at our statements, the only thing different in how they look is which way our inequality sign is facing. And that is, in fact, the only thing that will dictate how I translate these statements after getting rid of my absolute value signs, because my question is asking about x. Therefore, really, I don't care about absolute value of x. I want to know what each of these statements is telling me about x. So let's start with statement 1. Absolute value of x is less than 3. So this statement is telling us the distance x is from 0 is less than 3, which means, unlike with our equations, our goal isn't to solve for a single value of x here. Our goal is to just get a range of values for x. And to do that, it might be handy to use a number line. And so I draw a number line with 3 here, -3 over here. Now let's just start testing different values to see what x can be. So let's start to the right of 3. Can x be 4? It cannot, because absolute value of 4 is not less than 3. Can x be equal to 3? It cannot, because again, absolute value of x must be less than 3. It cannot be equal. But what happens when x is less than 3? And so can x be equal to 2? And absolutely so. All of a sudden, our numbers start to work, and we can say that for one of our ranges, x is less than 3. Let's keep going. Can x be 1? Yes. Can x be 0? Absolutely. Can x be -1? Yes. Can x be -2? Yes. Can x be -3? And here we finally have a no, because absolute value of -3 is equal to 3, which is not less than 3. So for our second range, we can say x must be greater than -3. Then we can combine our two ranges here, starting with this first boundary. So that means x must be less than 3, and x is greater than -3. And so we can just get a single range here. So when we have this sort of statement, this sort of inequality where absolute value of x is less than some number, that always gives us this between scenario where x is greater than -3 and less than 3. And so on a number line, that would give us this sort of single-tailed, closed loop solution. Now let's not forget to answer our question. And so the statement is still insufficient because we still can have multiple values for x. Don't forget our question is asking for just what is the value of x. So we still have multiple values here, so insufficient. What about statement 2? Now really the only thing different other than the numbers here, remember, is that we have an absolute value of x that is now greater than a number. Absolute value of x is greater than 1. So how does this change things? So if absolute value of x is greater than 1, let's do the same thing by making a number line. So here is 1 and here is -1. So maybe now, so let's start at 1. Can x be equal to 1? And it cannot, because absolute value of 1 is not greater than 1. So now let's go to the left. Can x be 0? It cannot, because absolute value of 0 is not greater than 1. So maybe then let's go to the right of 1. Can x be equal to 2? Absolutely. So if we keep going to the right, any of those values will work for x. So we know if we want to get rid of our absolute value sign, x can be greater than 1 is one option. We have this line now pointing to the right of 1. Then we got to continue testing in our other direction. And so we already said x cannot be 0. Can x be equal to -1? And x cannot be equal to -1 because absolute value of -1 is equal to 1. But what about -2? Absolutely. X can be -2 because absolute value of -2 is equal to 2, which is greater than 1. And so when x is less than 0, x has to be less than -1. So that is our other range. So when combining our two ranges, it's a bit different than our first case. In our statement here, in statement 1, we had this AND scenario where x is greater than -3 and x is less than 3. But here, we have this OR scenario. X is greater than 1 or x is less than -1. And so when we diagram that on our number line, that looks like this open-ended two-tailed solution, whereas in our first statement, we had this closed single-tailed solution. So again, let's answer a question, and this statement is still insufficient because here now we have infinite values for x. In statement 1, we had multiple values, but we didn't have infinite because remember, x has to be an integer. Here we do have infinite, and so statement 2 is definitely insufficient. So now if we are combining our statements, we just have to think a little bit. And so one way we can approach it is by breaking down what we know about x when it is greater than 0 and when it is less than 0. And so when x is greater than 0, from statement 1, we know it's got to be less than 3. And from statement 2, we know it's got to be greater than 1. So remember, x has to be an integer. And so knowing this, this actually means if x is greater than 0, x has got to be equal to 2. And then we can also look at, well, what do we know about x when it's less than 0? And so in that case, x is less than -1, which we get from statement 2. But from statement 1, we know it's got to be greater than -3. And so together, we know what? So here x can be equal to 2. Here x is equal to -2. And so we still have two solutions for x, which is less than infinite, still not enough to say sufficient. And so here our answer is E. So we went through these pretty thoroughly, but remember, I can translate these pretty much instantaneously when I see these sort of simple absolute value inequalities. I have them memorized in less than situations. That is when you have this between scenario. And in greater than situations, that is when you have this or scenario. So our between situation was also our and situation. And in our greater than, that's when you have your two-tailed or scenario. And all that determines which scenario you have is which way the inequality sign is facing. And so this is absolutely worth memorizing. But if you have to take a few minutes playing with a number line to understand why this is the case, then it's worth taking the time to do that. So we will continue looking at our simple absolute value expressions in our next video.